Alright, calculus. Let's talk about this Unit 5 test. So overall, there were several of you who did very well. And the people who did very well were those who had kind of internalized those 5.5 notes we took. So I'm going to have these over to the right side. And I'm going to reference them as I'm going over this. Here's what I'm talking about. This was what was on the screen when you were taking that test. And this is every single thing you need to know for this unit. The hard part is just applying it and interpreting it. So I copied it here, and I'm going to annotate the questions and then reference this as I do it, because I think once you see this, once you go through it once, you'll feel a lot different about each of these questions. So let's go through this one by one. I'm not sure how far we'll get, but we'll see. But number one, graphs of derivatives are shown. Which ones have relative maximum? So if I'm thinking about relative maximum, I'm thinking the derivative, I'm just going to abbreviate that, goes from positive to negative. So positive to negative. I don't think I mentioned that over here actually. This was all about concavity, so yeah, maybe the relative maximum stuff isn't on there. Sorry. But these are all derivatives. When do these go from positive to negative? Well, this one, h, never crosses the axis. G only goes from negative to positive. That's a min. And so f is the only one, and it happens right there. So the first answer is D, only f. Derivative goes from negative to positive. Number two, here's a function. All the answer choices are about decreasing and increasing. So I'm thinking in my head, I need to, step one, find the critical points. And step two, make a sign chart. So let's take a derivative. Let's see what happens. This function, oh boy, here we go. This function, the derivative, we get something like this. F prime of x equals 3x squared plus 12. And at this point, I'm already a little skeptical. This is where several of us factored and then got some wrong answers. So some of you said like, okay, 0 equals 3 times x squared plus 4. Let's divide by 3, because that's not a 0, that's just a constant, right? So 0 equals x squared plus 4. And then some of you moved that 4 to the left. You said negative 4 equals x squared. Are there any x values that would make that true? Then we think, like, wait, no, there aren't any numbers where I square them and I could get a negative. I could also have saw that up here. So this is my derivative. My derivative is shifted up from the axis and it opens upward, or it's narrower upward. So think back to your function families from pre-calc and algebra 2. This derivative, this is f prime, it looks like this, it's always positive. So if the derivative is always positive, it never crosses the axis, then my function is always increasing. This is a kind of mean question of me to toss at you, number 2. But like, you have the tools, right? You know if the derivative is positive, the function is increasing. It's always positive in this case. So keep that in mind. That one was tricky, but I know you have the tools. Number 3, this is the second derivative. If I want to know where points of inflection exist, I want to know where does f double prime change sign. I see it changes sign here at A and here at O. It doesn't change sign at B. It bounces off. So again, on your chart that you got, points of inflection exist when f prime changes direction or f double prime changes sign. So that's what we're looking for. This one, again, your answer was on the board during that test. Letter D is your solution. Number 4, 4, 5, and 6 are all the same equation. That was by design. I wanted to use the same ones so you didn't have to do 15 different derivatives. But I want a local minimum. So I'm thinking I need to find critical points. And then step 2, make a sign chart. So again, I'm annotating all these. This is what I would do when I was taking the test. I would say, okay, what exactly do I have to do for this? Then go do it. I think labeling and naming those skills is really valuable, especially as we get into the year and we have so many different things we're trying to keep in our head. So, step 1, find the critical points. We got 2x squared minus 4x. Factor this thing, I get 2x times x minus 2. So my zeros are 0 and 2. These are my critical points. So I know my relative min has to occur at one of those. Let's make a sign chart to see which one it is. So here's my sign chart from 0 to 2, f prime and f, and I know the derivative is 0 there and there. And now I'm going to plug in numbers in between each of those. So plug in 1 to the factored form. I get positive times negative, so I know my derivative is negative here. If I plug in 5 or something, positive times positive, definitely positive then. And if I plug in negative 1, I get negative times negative. Okay, that's positive. So my function increases, then decreases, then increases. Where does the min exist? My function's doing this. Min exists at 2. So 4 was B. Number 5, local maximum. Look, I already did all the work for it. The local maximum's right here. That's where it increased before it decreased again. So at x equals 0 is the maximum. There's my answer, C. And then 6, point of inflection. Find second derivative. Find the second derivative. And then you could say, like, make another sign chart, right? So make a sign chart to figure out where the heck the second derivative changes sign. So it's the same function. I'm going to just take a second derivative right away. So y double prime equals 4x minus 4. I can solve this now for that x value. So 0 equals 4x minus 4. And x is going to have to be 1. So when I make my sign chart, 1 is the only potential inflection point. Remember, I don't know if it's an inflection point yet. I'm going to assume it is because it's a line, right? It's definitely going to cross, but at this point it still is a potential inflection point. If I plug in a bigger number than 1, like 6 or anything, this is positive, on the left it's negative. So I know I'm concave down and then concave up. So my point of inflection does exist at 1. I think you probably could have seen that before doing all that sign chart, but if you still needed to, there it was. Number 7, this is one of my favorite questions. I gave you the derivative, and I want to know where is g decreasing and concave up. So I have a derivative function. We're interpreting it in 2 different ways. So if I have the derivative, and I want to know where g is decreasing, I want to know where is g prime negative. So let's actually highlight that right now. I'm going to go through, I'm going to highlight that. Alright, sorry for the hard cut. G prime is negative on these 2 chunks, right? This is G prime. Negative just means below the x-axis. The second chunk of this, where is G concave up? Let's look back at this table we made, right? G is concave up when the derivative is increasing. So let's head back to our graph. Let's label that, and then let's highlight it. Concave up, where is G prime increasing? I think it's increasing from here to here. And so my question is, where are both of those things happening at the same time? They're both happening at the same time on this chunk right here. Sometimes when I highlight, the colors kind of blend together and it's really nice. But this time it didn't do that. But I can see they're both highlighted for that chunk. So C is my solution. This question is tricky. You just got to take it one piece at a time. You could have sketched the second derivative too. That would have given you the right answer. I'm fine with either. But it's definitely all about, like, how can you take each piece and put it all together. Number 8. This was a really commonly missed question. I gave you the derivative. Our goal is to figure out where G... Oh my gosh, OneNote keeps crashing on me. Okay, our goal is to figure out where g is decreasing. So we're given the derivative. That's where, looking at this fact, that's our goal. Where is g prime negative? A lot of you had this interval from -1 to 1. So you said D. That is a chunk where the derivative is negative. That isn't wrong at all. But my question for those of you who did that is, what do you think's happening between -2 and -1? Like what if I tried to plug in -1.5? What would be the output of g prime? We're given that it has exactly 2 zeros here, so I know it's still going to be like -2 or -1 or -0.5. I don't know what it is, but I know it's still going to be negative all the way up until I get exactly to -2. And then at -2 it becomes 0. So we actually need to include a larger chunk, but an open interval from -2 to 2 to account for all of those decimal values between the two. This one's a little bit tricky, but those of you who made a sketch actually were great. If you make a sketch here, -4, -3, -2, it's positive, it's 0, then it's negative, negative, 0. And then you said, oh, I guess it is from -2 to 2, right? So make a sketch if you're unsure. It shouldn't be D, it should definitely be C. Number 9, this is my favorite question on an AP test ever. I love it. Somebody asked me, what is your favorite question? It's this one for sure. So I love it because it's asked so simply. But you have to just like know your functions really well. First of all, you could have solved it by making a sketch. But I think there's a more elegant solution. We can say 3 things about this graph. The first thing, I know when I plug in 1, I'm going to get 0 as an output. I can see it right here. It's crossing the axis. The second thing I know is that this function is increasing. I think we can see that. It's definitely increasing the whole time. So what's true about my derivative? I know f prime of 1 is greater than 0. The third thing I know is that this graph is concave down. It opens downwards for sure. So what does that tell me? That says f double prime of 1 is less than 0. And so if we were ordering them from least to greatest, it goes, this one is the lowest because it's negative. This one's in the middle because it's exactly 0. And this one's the biggest. And so B is our solution. What a question. We just have to know our 3 facts and apply them in a tricky way, and we'll get it right. So ask somebody if you got a question about that. Write out your hints. Annotate as best you can, and you'll get it next time. Number 10. Here's a function. When is it concave up? This is, I think I pulled it straight from Delta Math, but concave up. Again, make yourself a note. And I'm not going to scroll all the way up because I'm worried about one note crashing again, but concave up means f double prime is positive. So that's what we're looking for. When is f double prime greater than 0? Find 2 derivatives, make a sign chart. Here's f prime. I'm going to be a little sloppy because it's a multiple choice question. We can be. So here's f prime, here's f double prime. 6x minus 12. Set that equal to 0. Solve for x. Add 12, divide by 6. So 2 is my only potential inflection point. All these others about 0 and 4 and 6, I think that's if you take 1 derivative. Those are some zeros. But in this case, 2 derivatives. Just use 2. So f double prime and f. I'm going to plug in 0 into my second derivative. 0 minus 12, that's negative. Anything bigger than 2 is going to be positive. So it's concave down and concave up here. So I see that it's concave up when x is greater than 2. So anything to the right of 2 has a positive value. So A is where x is greater than 2. I'll pick up on number 11 on the next video. Keep thinking hard. Keep doing corrections. Figure these out because you'll definitely see them again. Keep it up.